So very, very warm welcome to everybody that's joined us. In this webinar series today, we're going to be talking about the day the Wi-Fi went down. And we are really lucky because we've got some extremely special guests on the show, some real stories from some real network owners. So I would love to introduce to you, obviously we've got myself, Mac, your favorite psychic Stu. Dale is back again to join us for this webinar to talk about his experience for, he joined Ekahau around retail, but then we have got the amazing John Kilpatrick. So very warm welcome to John joining us again. He's a fan favorite of the webinar series here at Ekahau. So thank you very much for joining us, John.
Hey, no problem. Good morning.
Yeah, good morning, good afternoon, good evening, good day, whatever time of the day it is for you all. So yes, I think Stu, you had a very good story or an example that you wanted to talk to us about, about when the Wi-Fi is down, work stops, and one of your experiences.
Yeah, it happened quite some time ago where working in a kind of a distribution facility, and what happened is that the Wi-Fi's got an outage happened, and you kind of figure out, well, what was that outage, right? And the RF scanning guns, they just not working in the warehouse. They need to scan product, get it out, and operations are definitely impacted, right? Because, well, products can't be shipped, and you're trying to get people moving. And what happens to the folks that are in there, the associates working? Well, they have to sit around and wait, right? They can't manually do it. It's they need a device to do to get the job done. And when wireless is down, that's really sucks, because then the supply chain suffers, because, well, then backlog happens and things get on. And then by the time that you kind of figure out what's going on and you've got nobody on site with any tools, that's a lost productivity, right? We really kind of can't get anything done. And that puts all of that stuff onto the next shift and the next shift over. And so it really is a chain effect down the line. And then it really kind of is like, well, your product was supposed to ship today, but it's going to ship tomorrow. And then that really kind of stops some things. And having something out in the field, like locally, like a testing tool to figure out, hey, what's going on? How do we kind of triage this? But having those tools actually save this day, because you're not losing $30,000 an hour or whatever that number might be. You're now needing, okay, great, I've got someone in the field that can grab some triage information for me, and then now we can kind of better approach the problem. But yes, but when the Wi-Fi does go down, work stops, and it's not funny, because it's not helpful, because you as an engineer are extremely stressed, and you really don't want to have that stress on you. I mean, I'm sure many of you have had that before in your careers, that when a P1 outage happens and it's on the other side of the country and you're on one other end and you're trying to kind of juggle things, it really isn't a great part of your day. So that's
well, it is a little bit funny, isn't it? And
well,
also, I think you had a great tip for us. If you ever get stressed as a Wi-Fi engineer, go behind the corner on the street down the block and buy yourself a cheeseburger.
Right. Yeah. Because don't get stressed, right? I mean, if you get stressed and you're sitting there trying to figure, what is this problem? I know the answer and I just can't figure it out. And I'm like, I've tried everything to fix it. And then it's like, you know what? Yeah, go grab a cheeseburger. And I tell you, the problem will then present itself. And then you'll be like, hey, now I know how to, I'm the superstar now. I can fix it. So that is one thing I've learned over the years to do is when the going gets tough, is that it's take a step back, observe, and then kind of and then go attack the problem.
It's that moment of panic that sits in, when you're hands-on and you're trying to troubleshoot an issue, and it could be the most simple thing, but you're jumping to conclusions and thinking, oh, it might be this, it might be that, and rather just going through like a methodical step-by-step process that you normally would take in a relaxed environment, because you're feeling stressed or under that pressure, you don't think in your normal logical way of diagnosing something. So sometimes it's good to take that step back, take a moment.
It is, right?
That's what you want to get, but
Yeah.
and then come back and look at it again.
But it is, because if you're sitting there and understanding the operational impact, because you've got the business over top of you, right? Saying, hey, hey, why isn't it working? I need an update. Can you update the ticket? Well, I'm trying to fix the problem. How can I update? That. So sometimes you just have to take that step back, see what's happening. What could the logic? Because if you start clicking buttons and changing things, it may not be what it needs to be changed, right? So yeah, I mean, always look at methodical approach, right, Matt? Because you really have to. We learn that in our classes. Look for the observe the problem, as one fellow says it. We observe it, and then kind of like, okay, how do we attack it?
Yeah, I mean, if switching it off and then back on again doesn't fix it, then you really got to go through your documents and figure out those steps that you need to take.
Absolutely.
So we have our first poll question today, because what we really wanted to know is, what is it that keeps you up at night when you think about the Wi-Fi going down? So Mac, as I launched this poll, would you mind doing the honors of reading that?
Of course. So guys, what keeps you up at night when you think about Wi-Fi going down? A, a neighbor moves in and completely wreaks havoc on my channel plan. B, Wi-Fi drops in the middle of an important conference call with CEO, of course. C, network failure in a critical infrastructure area. D, unknown or unplanned non-Wi-Fi interference coming online and killing the Wi-Fi, like video camera, microwave, or whatever else.
I know which
Really
one I
looking-
want.
I think I know which one John would choose as well for some reason.
Yeah, no, I'm gonna be going with B on this one. It's actually gonna be an element of
Yep.
what happened to me. It's like, wow. Seems a little personal, guys.
You might have had some influence over the answers in this question, John. Who knows? But we will just give it a few more seconds to allow everyone to get their chance to vote, and I will stop the poll and then share the results. So I will end it now, and then let's share so we can all see. And we can see that,
Wow.
quite a big chunk network failure in critical areas, infrastructure areas. So
It's not Wi-Fi then.
But also a lot of people worrying about, the CEO, John. So you don't seem like you're alone there.
No, and it's funny because I saw a comment go by, and so as someone correctly pointed out, a lot of the things that are called Wi-Fi failures are actually failures of other services that the user relies on. Now, if I go to a user and say, well, it wasn't the Wi-Fi, it was the DHCP server, they don't really seem to care. They're like, no, the Wi-Fi was busted. And I'm like, okay, fine. Wi-Fi has become the catch-all term for the entire stack of technology that gets packets from your device to the internet. And we take the hit for a lot of things that aren't our fault. And that's just kind of the name of the game sometimes.
Exactly. The Wi-Fi is down or the Wi-Fi is broken, I think, is probably the most common or well-known statement for if there's a problem anywhere. Like you said, if it's a DHCP server, a firewall change, or something else, it's always the Wi-Fi's problem. Poor old Wi-Fi. But anyway, John, we've got a very, very nice looking building here and a story, I believe.
Yeah.
Tell us about what happened to you.
Right. So we had just moved into this building. We had just completed construction. We'd been in there about 3 months, I would say, maybe a little less. And we started getting complaints. The COO had reached out to us directly and said, hey, I was having Wi-Fi problems during this call, whatnot. And it was getting worse. And we could tell we were starting to get more and more user reports. And the symptom that was reported was that Wi-Fi just wasn't connecting. It was getting stuck while trying to connect. And we went over there and we engaged the vendor, of course, and we started troubleshooting. And it was very, very, very odd behavior. The access points were just stopping to respond during the middle of the association process. And we were looking at these logs, and the logs were a little bit obtuse. And one of the biggest challenges that we had was the vendor wanted us to get a packet capture of one of these failed associations. Now, in a highly dense environment, right, that can be a really big challenge. You really have kind of two approaches. You either need to have some way to do a capture on an incredible number of channels at once and hope you catch what you're looking for. And we tried that a few times and just weren't successful. What we ended up doing was we had found actually, and I'm sure people are going to ask, and I don't remember the name of it, but we found an app on Android that let us look for and choose a specific BSSID to join. Now, while we're doing all this, it was really, really strange. More and more APs started having this problem, and it was sort of spreading through the building like a cancer almost, or like a disease. Classic epidemiology. As APs start to fail and fail, more and more of them start to fail. And the CEO and executives were, they're on calls, they're having problems. They started having to carry around MiFis just to get their job done, which is not a really good look for a company in their latest flagship building. So once we had figured out how to get the data that we needed, which was how to capture this failed association in flight, it turned out to be that there was a bug in the code on the access points that was causing the association ID to leak. Now, if you haven't delved deep into the association process, if you haven't taken, like, for example, the CWAP exam, which would cover this in detail, it's basically a numeric tag that gets tied to every association, every connection to an access point. And normally what would happen would be those numbers get reused, right? It's like, like memory in a computer, it gets allocated and then it gets recovered. Well, this wasn't, the AP was running out of association IDs, and that would cause the AP to just stop responding. And so this AP would look perfectly nice and perfectly happy. Rebooting the AP did solve the problem. That's obviously a little less than ideal. We started to get very clever. We were looking for, so we had to go through our logs and look for APs in busy areas that had no clients connected, because that would be a symptom. And the reason why it started spreading was because in a dense area, when one AP would go down, its clients would roam to another AP. That AP would then exhaust its pool faster, and then eventually everybody was just on a few APs, and then they were all dead, and we started rebooting them. This wasn't a controller-based environment. We also ran into a bug where the AP and the controller were able to run with different firmware. So that was a little extra bit of fun that we really appreciated, because that's never supposed to happen. There's supposed to be always a tight sync between the firmware on the controller and the firmware on the access points. So eventually, at the end of the day, I would say it's one of the most obscure, and probably, even now, this was 4 years ago. And even now, 4 years later, I'm not sure how I could have better troubleshot it, just because of the challenges of, how do it throws together all the worst things. You need an over-the-air capture. This was before the Sidekick, right? So that really limits your tools. So, I had to bring in a Mac from home, because doing packet captures on a PC without a Sidekick is just not remotely fun. At least it wasn't back then. I don't know if things have changed, but you're in a dense environment. You don't know what channel the client's going to try to associate with when you're trying to get your packet to capture. Yeah, it was. And then the thing that was so frustrating was the moment we had the packet capture, like 30 minutes later, the vendor's TAC came back to us with a bug ID, and we're like, really, guys, you couldn't have just taken a guess for us, and you really, really absolutely needed to see that packet capture. You absolutely had to have it, because even they didn't have any really good suggestions on how to get it. So yeah, that was a good time, and I have never been happier to apply a patch to a controller in my life, because obviously once we patched the bug, everything came back to normal, and we went our merry way.
Yeah, I can imagine the relief when you finally patched that and stopped that issue. But one of the interesting things I got from that, John, is that fact that you said that people weren't necessarily associating to like the AP that you was expecting them to, and they were associating to another nearby AP. So that must have meant that when you did your design for the building, you had supplemented in enough secondary coverage, because if you had an area where only one of these access points was just providing that primary coverage without any secondary coverage from a nearby access point, because when you want a high performing wireless network, you really need to have that redundancy and secondary coverage between access points, because people think, oh, an AP is going down is the only type of failure, but no, you can have software failures like you had, John, like you mentioned about not being able to associate to the access point because of that association ID problem. But because you had secondary coverage surrounding that access point, your clients were sometimes still able to connect. So it seems like you obviously designed for that in mind.
We did design for secondary coverage. It's there's a few failure scenarios you always want to keep in mind. You can always lose a switch, which could take out more than one AP. and so some striping in terms of primary and secondary coverage is always advisable. And yeah, it's, we were fortunate that we had enough coverage. If we had just done a bare minimum deployment, this likely would have been a much worse problem, because once an AP went down an area, that would have taken out that area. So it definitely, the design helped. The only downside to it was that it did a little bit complicate the troubleshooting process in this one case. Just keep in mind that if you're in an environment where you might need to do packet captures and you have a lot of APs, just figure out how to do what we did, which is how to be deliberate about knowing which channel you want to capture on. Having a tool at your disposal that will let you, find a piece of software that will let you pick a specific access point to join to will save you a lot of trouble.
And that's a great talking point. Let's stay here for a few minutes, if you guys don't mind. So you said you don't know what channels to capture on, because it is normal in Wi-Fi that Wi-Fi devices will be associating to different APs, not always the best IP that they have nearby. They will have different firmware, different algorithms that will sometimes work in a way where your Wi-Fi device will associate to second or third or fifth best IP in the area. So let's talk about association. Matthew, shall we?
I would love to talk about association. So for anyone that is not too familiar with Wi-Fi and what John was talking about, that association process, that is when the client device was connecting to the access point. So I'm going to explain the association process, and I'm going to explain it in a couple of different ways and concepts. And then Mac will talk to you about what's called the re-association process. So once you're already associated to one access point and then you want to move to another access point, that would be called the re-association. But of course, in Ekahau style, we want to do it in our own Ekahau way. And this association process is also sometimes referred to as the green diamond, which is this magic algorithm that happens in all of our client devices that make a decision for what access point they want to associate to. So what we have here is that we've got someone that's looking at their mobile device, and they're looking at a food delivery app called the Ekahau app. So this is very similar to, if for example, like we have here in the UK, something that's called like Uber Eats, where if you wanted to go and order some food, you go in there, you type in the food you want, and you get returned a bunch of restaurants. I was talking to the guys over in the US and Canada. I think you've got ones called like DoorDash and something, Grab something. I can't remember. Grubhub. Okay, Grab something, Grubhub, similar. Anyway, so what happens when you go onto these applications and you go on there, and let's say you fancy a pizza. So you go onto the Ekahau application and you type in the word pizza. And what's going to happen is you're going to get returned to you multiple different restaurants that can serve you some pizza. And then you have to make a decision on why you would choose one pizza restaurant over another. So we can see here in this example that we've got 4 different restaurants that are ready to come and serve us pizza. We've got the Megahertz Pizza, we've got the Slice Kick, Krusty Corner, and then Penny's Pizzeria. But what I want to know is that what's actually important. So let's actually ask a few of the guys on the call. So Dale, since you're still up on my screen, if you're going to order pizza, Dale, what's really important to you for when you look for a pizza?
That Megahertz pizza is right there. It really stands out to me because of it's super spicy being advertised. I'm a fan of spiciness, so that's my weakness. So I'm gonna have to go with that. Yep.
Oh, that's fine. So Dale likes the spice. We got that. Mac, how about you?
I'm definitely going for the Slice Kick because the name is cool.
Okay, so Dale wants to have the spicy one. Mac likes the name Slice Kick, but also the delivery time is only 5 minutes. John, if you're ordering pizza, what is it that you look for when you order a pizza?
Well, I'm gonna be balancing a few things. I got to say that Krusty Corner is looking appealing. It's got really high ratings. It's nearby, and it looks like it costs a little bit more. So I'm probably gonna go with that and get a little bit of quality.
Okay, that's
unlike Stu. I don't go to fast food restaurants like McDonald's looking for cheeseburgers when I'm hungry. I look for quality.
Well, if I'm going to get a pizza, yeah, I'd agree. Yeah.
Matthew is all about the brand, never about the value, right, Matt?
Yeah, exactly. That's the same. But so, student, what would you be looking for if you was going for a pizza?
I definitely be looking for the Krusty Corner too, because I think I'm going to get quality and brand and speed. Everything, it meets the requirements for me. Okay. How about that? It meets my requirements.
So everyone on the webinar was thinking, Matt, why are you talking to us about pizza and making us hungry at this time? I come here to learn about Wi-Fi. And the real key thing that I'm trying to get everyone to think about here is that every one of us is different, and we all have our own set of reasons for why we would personally pick one pizza restaurant after another. Is it because of the type of, it's the spiciness that Dale was looking for? Is it because it's going to be able to deliver to us fast and it's cheap? Or do you look for quality and high ratings? Different, every single person's got different criteria, different reasons for what you look for when you want to order a pizza. And that's kind of similar to what we call in Wi-Fi, this green diamond algorithm, because it's always the client device's decision. So your mobile phone, your iPhone, your Android, your phone, your MacBook Pro, your Windows laptop, your iPad, is always the client's decision for which access point to associate to. So let's say, for example, was going to John's environment and we walked in there and we can hear 4 different access points from our mobile phone's perspective. And we can hear access point A, B, C, and D. Well, why would there's an SSID coming from all of those access points that we could associate to? Why would our phone decide to go with access point B over access point A, C, and D? And what is the reason why it would do that? And that's because it's got its own baked in green diamond algorithm. It could just be something as simple as, access point B has got the strongest signal strength, so I'm going to connect to the strongest signal strength. That could be a very, very basic green diamond algorithm reason. Now, there are some devices out there that have got a way more complex green diamond algorithm. Maybe access point B didn't have the strongest signal strength that was being returned back to the device, but actually it had the least amount of devices connected and the lowest amount of channel utilization. So that when it was making its decision for what it would look for to go and join, like, access point A, that's got a stronger signal strength, but it's got way more clients connected to it and higher channel utilization. So it means I've got less chance of accessing the network. I'm going to go to access point B. Yes, it's a slightly less signal strength, but I've got more of an opportunity to get connected to the Wi-Fi and then transmit my data over the air. So we've got a little list, a slightly longer list, but of all of the potential reasons as to why a device would prefer one access point over the other, and the potential metrics that's going into the green diamond algorithm, from anything from how strong is the signal strength, which is the RSSI, all the way down to what amendments are enabled. Things like, does it have 802.11k turned on, 11R enabled? Loads of different reasons and metrics as to why your device or your customer's device or stakeholder's device that you design the Wi-Fi for would pick a access point to associate to. Okay. Is everyone hungry now, thinking about pizza? Mac, you ready to talk about some reassociation now?
Always.
Okay.
So, and we'll also be talking about the amendments 802.11p for pizza and 802.11sp for spicy pizza later on. So guys, let's talk about this very quick example here. So Matthew has talked us through the association process. So when the access point when the client discovers multiple different radios it can associate to, it will make this difficult for the client decision which AP to associate to, which BSS ID, MAC address of a radio, specific radio to associate to. And it's always a client, okay? Or in most cases, it's a client. Sometimes the infrastructure tries to steer the client towards a specific radio, but ultimately it's the client's decision about which BSS ID, so MAC address of a radio, to associate to. So now let's talk about roaming, which is also called the reassociation. That's the technical term for roaming. So we are associated to our access point at the starting point, AP3, 5 gigahertz on channel 48. That's our current association. We are in the meeting room and the client is very happy there. The signal strength is strong, everything is fantastic. And now the client leaves the meeting room. And you can see that it's not only the wall that is now between the client and the access point in the meeting room. There is a column that is typically steel inside with some dry walls around it and metal cupboards. And there will be probably quite heavy attenuators to the point where the client will now start thinking about its next best AP. Its RSSI will drop to the point where for this particular client, it will make a decision to start looking for next better radio to roam to. And now In 2.4 and 5 gigs, there are two discovery methods, passive or active. Passive discovery method, so discovering the APs, the radios, BSSIDs that can serve you, is just listening to beacon. So clients will dwell on a channel. They will go off channel. So let's say if my client is on channel 48, it will probably go to channel 36, and then it will listen for at least 105 milliseconds, because the beacon target time of sending beacon by the access point is what? Around 102.4 milliseconds. So if a client dwells for 105 milliseconds, there is a good chance that it will catch at least one beacon on that particular channel. So waiting for beacons is slow, because client that is on channel 48, maybe it's on a voice call, has to go off channel to passively listen for a long time from Wi-Fi perspective to get that beacon with the information about what's available on the channel. So while it might do it, most modern clients, when they get to the roaming threshold, they will use an active discovery mechanism, which involves probing. So the client will go off channel, let's say to channel 36, and it will send probe request. And if there are any radios operating on channel 36, they will respond immediately with probe response. And probe response and beacon, they have pretty much the same information in them, and the client will now know about the capabilities, SSIDs of the radio that has responded to probe request or has sent a beacon. So now you can see that the client is quite close to the access point 2, and it knows about that AP. It's farther away from AP1, and it also knows about that AP. So while the client is moving towards AP4, the green access point on the right-hand side, it now makes a decision about where to roam to. And by the time it gets back to its desk that is just next to AP4, it might associate to AP1, it might associate to AP2. In this scenario, it has chosen to associate to access point 2, which now at the client's desk might be 10 or 15 meters away from that access point. And it has an AP just above his head that it will not even know about, because it hasn't discovered this AP. And it will not start thinking about discovering that AP until its RSSI threshold, in most cases, drops below the threshold for that particular client. And every client is different. For, let's say, MacBook Pros, the reassociation threshold, roaming threshold, will be next 75 dBm. For, let's say, an iPhone or a flagship Android clients, it might be something considerably higher, like neg 70. There might be different rules associated with different clients. For example, iPhones, if you are on a voice call actively receiving or transmitting data, they will be more inclined to join to the access point that might not be the best IP. If it's good enough for them, better than the current one, they will join that straight away. They won't wait until they find something that is, I don't know, neg 50. If it's 6 or 8, I can't remember, dBs above the current association, they will jump straight to it, and then they will continue scanning and discovering new APs. If you have your laptop, it might not have these mechanisms. So it won't even start scanning until it gets to neg 75, which already might be too low for an active voice conversation. So that's the quick roaming talk. Now let's move to the next slide and discuss what can we do to improve roaming. So reassociation, how can we do it faster without spending tons of time off channel scanning for better alternative while not receiving or transmitting packets, while having bad connectivity on our voice call or video call. So the first thing, and probably one of the most important things that we can do if we are using .1x suite, is to use 802.11r. Imagine if we have a radio server sitting somewhere in the infrastructure. Sometimes it's in the same floor, in the same building, sometimes it's in a different country or even in a different continent. And then physically, even if you have a fiber between these two buildings, you will have an RTT of 300 or 400 milliseconds. Plus, when you add all the time that the servers they need to use to respond to your radios and query, it takes time. It can even take seconds. And every time you jump between access points without 802.11r, when you do use radios radio server for your re-association, re-authentication, it might take seconds. And what would happen to your voice call if you take seconds when jumping from one AP to another? It's either bad quality or it's completely gone. So with 802.11r, we now don't have to go back to the radio server every time you want to roam between different APs, because the authentication result is cached across all the APs that you potentially would be able to roam to. And all you need to do is just a fast four-way handshake. That takes tens of milliseconds instead of potentially seconds. So that's 802.11r, very important. Use it just on .1x enabled SSIDs that do use radio server pretty much. If you use PSK, you can still enable it, but there is really no need for that. Now, another very important improvement to roaming is 802.11k, which uses something that is called a neighbor report. This is very, very important even when you design your Wi-Fi network. I typically always when I design networks for roaming, I have 802.11k on the back of my head, thinking I need to put access points in a way where some of them on the roaming path, they hear each other. And now, why is that the case? When you are associated to your current AP and you start losing your RSSI to the point where you want to start roaming or discovering new APs, you will go off channel, you will start panic scanning. It might take tons of time for your client to find that one next best radio. You have 39 channels to scan on just 2.4 and 5 gigahertz, and it can take you seconds until you find your next best AP and associate to that. So how does 802.11k work? If you get to the roaming threshold, instead of going off channel and randomly scan some channels hoping to find a better AP to roam to, you can ask your current association, your current AP, your current radio, hello, Mr. AP, what are my best options if I want to roam now? And then this AP will send to the client on the same channel it's on the list of its own neighboring APs. Typically, it will be 1 or 2 or 5 APs, not 39, back to the client, and the client will then go off channel to scan just this 1 or 2 or 5 APs, and that will be way, way faster than random discovery scan. So both 802.11r and 802.11k are extremely, extremely important. And then lastly, there is 802.11v. I haven't seen it breaking things. I know that some Wi-Fi pros, they have it in current state of things in 2.4 and 5 gigs. What we use from 802.11v is the ability for the infrastructure to suggest to the client to jump to a better, from the infrastructure's perspective, radio. For example, if the Wi-Fi controller or the cloud controller or whatever, it knows that you are associated to very close AP, but you are not alone. There are 70 different clients associated to that AP. And even if your RSSI is extremely strong, the access point 20 meters down the corridor, or hopefully down the open space, not a corridor, will have still good enough RSSI, but they have 5 clients associated to that AP instead of 70. So lower RSSI, lower MCS rates, but less contention. You might be better off connecting to that one. So infrastructure can tell your client to go there and connect to that AP. And what would most clients do? Nothing. They will ignore it. And then the infrastructure can suggest again, oh, Mr. Client, connect to my friend, and then client ignores it. And it happens a few times. And then the infrastructure can kick the client out ungracefully. So the voice call is over. And then when that happens a few times, for example, iOS devices, they can blacklist entire SSID, and that can cause theoretically problems. I haven't seen that myself, but it can happen. So that's how you can improve roaming, by using correct design and correct configuration for different authentication methods for your SSIDs.
Yeah, and a few questions that have come in regarding this, Mac. But the one thing I just want to point out here that we've got in at the bottom is always make sure you test with your real client devices. So what we mean by this is that don't just enable 802.11r on your SSID because you came to the webinar and heard us talk about it, because some of your devices in the field, they may not support 802.11r. So if you enable that on that SSID tonight, and then, you know, people come into work tomorrow morning and they can't connect, it might be because the devices, they don't support it. So it's always really worth checking to make sure the devices will support the stuff that you want to turn on, and make sure you test as well so it doesn't cause you any issues. So yeah, a few things to think about there. Another question was that if you've got an open unsecured guest network, is there any value on enabling 802.11r?
You want to answer that, or are you asking me?
I was going to let you answer, but I did type an answer to them already, but I thought I would let you answer.
Okay, there is zero benefit in enabling 802.11r on open networks.
That's what I said as well. Okay, perfect. So over to Mr. Dale now, who's going to be telling us a nice story about some of, maybe it's not so nice a story for Dale, but it's nice for us to hear it about some of the stuff he experienced with his retail Wi-Fi days.
Yep. So thanks, guys. So, you know, with us talking about food and everything, it being lunchtime, I figured I'd present a sampler plate of some of the issues that I've seen over the years as it pertains to the day Wi-Fi went down. Now, in many cases, it's not necessarily Wi-Fi going down, but as long as the end user notices on their mobile device that they interact with and the application is not working as expected, chances are it's going to be classified as a Wi-Fi issue. Now, some of these issues, I'm going to break down the situations or just give you a quick overview of what I've seen over the years. Some of those might be due to an ACL or access control list or firewall change. You know, some of the impact that might have, it might be due to a wrong octet being listed in a firewall rule, bad subnet mask or something along those lines. Impact could be certain applications not being able to reach their destination servers or access points not being able to talk to the controllers. Another issue we've seen over the years, loss of VLAN mappings on the access points. In that case, you might see certain SSIDs being assigned or corresponding with a different VLAN that's not attended. And some the impact you might see is DHCP pools becoming exhausted. Clients can't get an IP address, no longer able to communicate.
That's a really good one, Dale. That one you said about VLANs not being configured either on the AP or on the switch for an SSID. I've seen that happen so many times. And you go to the site, you check the Wi-Fi, and you can see that SSID, and you think, oh, okay, I'm going to associate to the SSID. You try associating, but you're even not getting put into the correct VLAN, which is an issue. And then but to the user, it's just, oh, the Wi-Fi doesn't work. But you know, Wi-Fi is working because you can see it, you can connect to it, but you just don't get assigned into that right VLAN to get that traffic and assigned what you are supposed to be assigned to. So that is a really, really common one and a good one as well.
Yeah, and all the while coverage looks good on the device, and they're like, okay, why is this not working? I have good coverage, you know, but it's a lot more to that. You know, another thing we've seen is like during certain changes, when we change our class of service profile, for example, it is important to, in some cases, prioritize that CAPWAP traffic. In our case, it was because those, you know, the APs need to be able to talk to the controllers, at least in our case, for control plane and management plane traffic. So we seen, you know, when that wasn't prioritized, we lost the ability for the APs to talk to the controller, but we had tools to be able to identify that. Global RF profile changes, for example, or changing global settings, even those that you might think might not have a big impact. I think of a recent example of noticing something in the interface in the whole GUI of our controller that changed, where we had disabled SSIDs, or sorry, data rates at the SSID level. Well, that changed and it became a setting you had to do at the RF profile level. I noticed that some of those data rates that were disabled at the SSID level were enabled. So, you know, I said, okay, well, let me correct this. I did that. What happened was we saw a bunch of AP radio resets all at once. Clients lost connectivity. Now they try to reassociate, but all at once, try to reassociate to our Radius servers, overloads those, even though we had multiple PSNs in this case, multiple nodes in that deployment for Radius, but also our DNS servers. So when they tried to talk, they overloaded the DNS servers. It wasn't about till a half hour that you know, the information reaches my network engineering team. You know, the store associates panic, help desk hears it, network operations hears it, then it comes to the network engineers. But you know, that half an hour where they were experiencing was kind of a big deal. And unfortunately, it wasn't until, you know, that amount of time later that we heard about it. firmware upgrades. You know, sometimes when you do firmware upgrades, it introduces bugs, as we all know, and it's bugs that even though you might have tested in the lab, you're still not going to be able to identify those. You don't see those until, you know, actual production deployment and rollout. We've seen that a number of times. It might affect mobile printers, might impact our VoIP phones. You end up spending a lot of time in some cases with TAC, you know, so the technical support teams of the vendors on the client device side, but also the AP manufacturer side. That requires getting a lot of packet captures. Sidekick is definitely something that comes in handy for that, because in some cases you may want to perform the packet capture at the access point side, but sometimes you want to do it at the client level, right where the client devices are. Being able to have a device like the Sidekick pick out channels that you want to do specifically, that you want to assess, very helpful. I'll give one more. You know, there's a list of things I've seen over the years, but you know, also DFS events, you know, radar events, for example. If you have DFS channels in some retail locations, there may be radar events that impact that whole RF environment. APs go off channels, clients lose connectivity for an amount of time. So these are just some examples of different things that I've seen when Wi-Fi went down at the retail locations in which my team were the network owners. And when we talk about the impacts of some of the downtime, you know, potentially you lose revenue potentially. For example, we had mobile or wireless point of sale devices. You know, if those devices, let's suppose a customer's in line, transaction takes place, they can no longer do that wireless transaction. Now they have to go stand in line. They may say, okay, I'm coming back later, or never mind, forget it. Just one example. You know, customer Wi-Fi goes down for some reason. Now, and many times in malls, we noticed that users had no cellular connectivity, but they might be utilizing your app. They want to pull up a coupon. They can't do that because they have no cellular connectivity. If Wi-Fi is down, now they can't even use that. They start complaining about that. Store associates hear it, help desk hears it, and then it trickles down to the networking team and then upper management. And then many times, you know, when Wi-Fi is down, there sometimes are workarounds. You revert to more manual processes. Now, a lot of times associates that are trained and familiar with doing those non-manual processes, they're not too happy whenever they have to revert to those methods. And again, those are things that you end up hearing about. So all in all, when Wi-Fi does go down, you do see a loss of operational efficiency, and as well as panic to some extent, all across the chain, from the customer, then to the sales associate, to the help desk, to your NetOps team, to the engineers, and then, you know, upper management wondering what's going on. So these are some of my experiences that I have seen over the years when Wi-Fi, quote unquote, went down.
Sounds stressful.
Yeah, when you talk about being panicked, I just had an image come to my mind, and this is going to be the dorkiest thing ever. But you remember in Empire Strikes Back when Han Solo is trying to get the Millennium Falcon running, when they're trying to escape the Ice Base Hoth and like the stormtroopers are all coming in? Yeah, it's like that, but worse. That's the image that comes to my mind when it's down, everyone's pointing at you. Yes, I'm a nerd. Thanks, Patrick. That's exactly what it's like, though. You got people asking you, offering you helpful suggestions, and that aren't that helpful. And I'm just guys, leave me alone. I'm going to fix this. So yeah, it's part of the gig, and you get a lot of adrenaline. And when it's over, you can think, oh, that was kind of fun, but it's definitely can be stressful while it's going on.
Yeah, you definitely get a rush, to say the least.
The point of sale thing going down, that's happened to me multiple times. I remember even recently I was somewhere where I was just buying trying to buy a coffee, and I went to go and pay, and the terminal was down. I was trying to pay, and I never carry cash anymore. I always use Apple Pay. And they said, oh, our point of sale system's down. Can you pay by cash? And I was like, no, I don't even take a card with me now out to go and withdraw cash. I only pay by Apple Pay on my mobile devices. And they're like, well, we can't pay, the Wi-Fi's down, the point of sale's down. So I couldn't pay for the coffee. So in the end, they ended up giving it to me. I felt really bad, but I just had no way of paying for it. So when the Wi-Fi goes down, people are losing money. It affects businesses, even from very small to just a few pounds or dollars for a coffee, to what Stu was saying, only like $30,000 an hour some businesses are losing when the Wi-Fi goes down. And
yeah, so actually 2 weeks ago, I refueled my car and couldn't pay for this exact reason. But I was extremely lucky because for the first time in my life, I did notice the ATM, a cash machine with a contactless terminal. So I tapped my watch against the ATM and I got money out that I could pay for my fuel, which is funny. It is.
Are you lucky?
So very lucky. Yeah. Otherwise, I think it would have been, I don't know, like a police situation. Anyway, guys, let's answer a question or two before we continue. So the first question is from Heng Dian. If one AP broadcasts two SSIDs with the same channel, would both SSIDs overlap on that channel? So let's answer that quickly. I know that for some of you guys, it might not be super clear. So if you have multiple SSIDs broadcasted on a single radio, they will not overlap, but they will consume more airtime, because on that particular channel, for every single SSID from every single radio, you will see around 10 beacons per second. So if you have 10 SSIDs configured on a single radio, then you will have 10 times 10 beacons per second, which is more than 100 beacons per second, actually. So that will contribute to the airtime utilization. And the beacons and all control and management traffic is being sent at the lowest configured basic data rates. And out of the box, it's very low, like 6 megs for 5 gigahertz is typically what you would see from most of the vendors. So if you have too many SSIDs on too many radios and tons of CCI, channel contention, channel overlapping, both things combined would kill your Wi-Fi capacity quite considerably. So that was one question. Hope it makes sense. And then another question, what happens if we deploy a wireless network without enabling 802.11r or K? Very good question. And the answer is Sam Clement style, it depends. If you don't use any authentication or encryption, it doesn't matter too much when it comes to 802.11r. 802.11k, for example, it should be enabled every time for every network. It doesn't matter what you use. AP discovery process can be slow. 802.11k will speed it up. 802.11r should be used only on 802.1x networks. That's it. Let's continue.
Sure. So whilst we were putting together this slide deck for today's webinar, there's way more of us in the marketing team at Ekahau that put this together. And there was a guy that is watching now, he's thinking he's going to kill me if I say who it is, but he told us a story about what happened to him when the Wi-Fi went down when he was back in college. And I thought, well, that's such a great example. We have to tell it on today's webinar. So I hope I do it justice, but what happened to him is that he had to submit an essay he was in his dorm room, and he was getting to the point where he had to submit an essay for an upcoming test, or I'm not sure what you guys call it in the US, but maybe his assignment was due, and it got to 3 p.m. and the assignment he needs to be handed by at 11 p.m. and at 3 p.m. the Wi-Fi went down. So no one in the dorm rooms could submit their essays for the assignment. And because the Wi-Fi was down, they had no way of doing it. And then it got to say 11 p.m. and they missed their deadline and they wasn't able to submit their essays. And then the following day, when they went into the class or the lecture and they spoke to the teacher or the lecturer, they had to explain that, oh, we couldn't submit our essays because the Wi-Fi went down. And the lecturer or the teacher was thinking, oh yeah, that old excuse, my dog ate my homework. But they all had to come together and was like, no, really, the Wi-Fi went down, so I couldn't submit my essays. So they had to get an extension for when they could submit, because the Wi-Fi had gone down. They had no way of submitting their essays. And it's more than just for like universities or college and dorm rooms. We see so many schools now that run on Wi-Fi. So many schools now have mobile devices like iPads that they're running these applications for. They go into the classrooms, they're getting told to go onto certain applications to do things. Homework's done through there. Did you guys call it homework in the US, or is that just a term for us?
Yes.
Okay.
Yeah. Stu, you're Canadian. You wouldn't know what we do in the US. Yes,
right?
We call it homework
Yeah.
in the US.
Yeah, we're just good listeners. We look over the border and see.
So yeah, we see, Wi-Fi is no longer the nice to have anymore. It's the business critical running for your businesses, or even when it comes to your kids' knowledge at school, the education running as well is so important. So we have one more poll question today, so I'll launch it, Mac, whilst you read it out for everyone.
Okay, let the poll read the poll, right? So I perform health check surveys, A, every 1 to 3 months, B, every 3 to 6 months, C, every 6 months to a year, D, I only survey for new deployments or when replacing access points, or E, I don't perform site surveys. That would be boring.
Mm-hmm. I know site surveys are so much fun, especially with the Ekahau mobile applications and the Sidekick. I mean, what a blast! Oh,
Blast of my life. Autopilot is always a blast of my life.
Yeah.
You know what my
I had a
favorite
friend
thing?
watching. I had a friend watching me do it. He said it looked fun, and I handed him the iPad and the Sidekick, and I said, "Sure, I'll teach you how to do site surveys." And then I sat down at my desk, and he ran around, and he was having a great time. And I was like, "Going awesome!" I got the data I needed, and someone had fun.
That's
the best thing about Autopilot is that I can have my mobile device, Sidekick over my shoulder, and I can have my lightsaber ready to go to take out all the bad Wi-Fi if I need to.
I was wondering how long it would take for the lightsaber to come out after John mentions the Star Wars story. I saw Stu's eyes light up, and I thought he's gonna get that lightsaber
Right?
out.
Yeah.
So really interestingly is that a lot of people said that they only survey for new deployments or when they're replacing access points. They're not performing health check surveys too often, which you know, considering how important Wi-Fi is these days, not performing health check surveys could be one of the reasons what could cause the Wi-Fi to go down. And one of the things that we really want to do at Ekahau is help all of you is keep great Wi-Fi every day. That's why we come up with our 3 easy steps to get that great Wi-Fi every day. One of the biggest reasons that we see poor Wi-Fi or bad Wi-Fi is because they've never had a design done, or the design that was done is no longer fit for purpose. It was done so long ago, it no longer meets the requirements. There's been changes. People want to use Wi-Fi in different ways now, so you would need to go and redo that design. You can then use, like Stu and John were saying about the sidekick, step 2, making sure that you validate your designs with super accurate sidekick measurements. It's such a blast. You can see it behind Stu and his Zoom on mine as well, that we take it with us everywhere. Every time we go on site, we're validating that we've got our design spotless, meeting our requirements. And then we finally move on to step 3, which is the health check surveys, which we were talking about, which we think is one of the most important types of surveys, because this is the chance to make sure that if we have any issues that are coming up, that we can stay on top of them. I like to say it's keeping your finger on the pulse of the health of your Wi-Fi network. If you're not regularly checking your network, things change, firmware updates happen, devices get their radio switched back on, people bring in devices, there's physical changes to the environment, people move around racks, people move around desks, knock down walls. So much stuff happens. People want to use meeting rooms in different ways, a different capacity requirements. So regularly checking your space by doing health check surveys is going to be one of the greatest ways that you can keep your Wi-Fi network high performing. Another thing that we want to announce, Mac, I'll let you announce the ECSC scholarship winner today.
Okie doke. So the winner of the ECSC scholarship, congratulations, is Joshua. I'm not sure how to read the surname. I will try my best. Fetechnai from Land Free, doing Wi-Fi solutions.
Yeah, massive congratulations to Joshua. You will be being contacted very soon, so you can come and sit on a ECSE design class. If you don't know what ECSE is, that's our certified training program that we have, where we teach you all of the fundamentals that you need to know to be able to design, maintain high-performing Wi-Fi networks using the full Ekahau suite of products. But
congratulations, Joshua. It's really amazing opportunity. We hope that you will enjoy it. But Joshua isn't the only one out there making the world a better place. A new hero has also joined the fight against bad Wi-Fi. And we can't wait to show you all about it in the next webinar. If you haven't already, be sure to reserve your seat today. And guys, I'm really telling you, this is going to be the best 60 minutes that you don't want to miss.
That's right, folks. Sign up now. Operators are standing by.
Yep. So if you want to sign up for the event, just scan that QR code. It's going to take you to the registration page, put in your details. It's going to reserve that time in your calendar. You're not going to want to miss it. We have got tons of demos, and we're just absolutely dying with excitement to talk to you about it and show you what it is. So please make sure you come and join us for this event that we've got in 2 weeks' time, this time in 2 weeks' time.
And yeah, that's going to be amazing. I'm already like super excited. Again, guys, I won't be able to sleep for 2 weeks straight. So when I'm tired, that's because of that event. So guys, like before we continue, let's do 1 or 2 more questions. So the question from Nick, what can we do during the Wi-Fi design process to decrease the chance of gremlins causing complete havoc on the wireless network? And the answer is, don't let them in. Lock your office after you're done with your work. It works for me, it works for everyone that I know, so I hope that helps. And another question is, in case we have only Uni 1 enabled and allowed, and Uni 1, for those that don't know, is just 4 non-DFS channels, channels 36, 40, 44, and 48, just 4 20 megahertz channels. Using 80 megahertz channel width, so we are bonding all of those available channels into one super mega gigabyte channel. Does it make any difference selecting channel 36 or 48? So I guess we are asking here if it makes a difference if in a bonded 80 megahertz channel where we have just one channel, does it make a difference if our primary channel is channel 36 or 48? And how did the client device get off channel at time of scanning for the other APs? That's a great question. So if we have multiple 80 megahertz channels using different primary channel, then devices, they will still have to go off channel, because for all control and management, we are just using single 20 megahertz primary channel, which will be channel 36 or 48. So these are two different channels. But on top of that, so we don't fix anything here, but we are introducing one massive problem called OBSS primary secondary overlap, which means that if we have clients on channel 80 megahertz channel with primary channel 36 transmitting or receiving data, and a client on the same channels but with primary channel 48 wants to send on or receive data, it will check, oh, is there any Wi-Fi transmission on my channel 48? And guys are banging the spectrum with, with channels 36, 40, 44, and 48. It will listen to it, and it will not hear a Wi-Fi 802.11 preamble on channel 48, because this has been sent on channel 36. And it will start transmitting thinking, oh, if I transmit now, I'm not going to disrupt anything. And what's going to happen? Collision. And collision means no acknowledgement for the frame. And it means retransmission. And that means slow Wi-Fi. So never use different primary channels on the same bonded wide channels. The best practice in 5 gig is just to stick to the first channel in your bonded channels. So if you're bonding 4 Uni1 channels into super wide 80 megahertz channel, always use channel 36.
There was a question that came into the chat about recertification for ECSE, and if we have any update on that. So what I just want to say is that anyone that has got the ECSE and it's either expired or it's soon to be expiring, we will have a solution for you soon, which we will be announcing. So stay tuned for that, but don't panic. We will get you everyone covered that's got a current ECSE, or if they've just expired or if they're about to expire their certification, we will have a way for you to be recertified. So stay tuned for that one.
That's it. And I don't think we have any more questions in the Q&A today.
So thank you very much, everybody, and we will see you on the next one.
Thanks, guys.
Thank you, everyone.
Bye.
Take care.
All right. Bye-bye.